Hello everyone, this is Dr. Surya. Today we are going to see about hydrostatic force on a plane surface. So what is this hydrostatic force? So this is the resultant force which is caused by the pressure loading of a liquid which is acting on submerged surfaces. That is merely a pressure that is acting on a surface of the fluid. Okay, and what are the forces that will be acting on a fluid particle? So the forces that act on fluid particles are one force we call it as body force and another force is called as surface force. So these are the two forces which act on the fluid. So what is this body force? So this act over the entire volume of the fluid element, and I can say that this is mainly due to gravity. That is, in simple, I can say that due to self weight of the fluid particle, if any force is acting on it, then that is called as a body force, that is self weight of the fluid particle. So next one is surface force. So this is due to the pressure of fluid which is normal to the surface. That is, it will act as a action of the surrounding mass of the fluid element, and these forces are called as a surface force. So what is the purpose of learning all those things? The main thing is that the determination of these kind of forces is very important when you are going for a design of your storage tanks or ships or dams or any other hydraulic structures. If you are planning to design any of the hydraulic structures like water tanks or ships or dams or whatever, any hydraulic structures, then you have to consider all these forces and then only you can do it off. So for that purpose only we are learning this topic. Okay, hope you understood why you are learning this topic. So these two forces mainly depend on that is act on the fluid particle. So before going into that, you should know another some of the terms called total pressure and center of pressure. Okay. So total pressure. So it is a sum of static pressure, dynamic pressure and gravitational potential energy per unit volume. That is, it's a sum of mechanical energy per unit volume in a fluid. So in simple I can say that it is a force which is exerted by the fluid on a surface. So whenever the fluid is coming in contact with the surface, and what are the forces that is exerted by the fluid is called as total pressure. So again I repeat, whenever the fluid is coming in contact with the surface and during that time a force will be exerted by that static fluid on the surface, and that is called as total pressure. And center of pressure I can tell is that it is defined as a point of application of the resultant pressure on the surface. So where that where that point of application occurs, so where the total sum of the pressure field acting on a body, it will cause a force to act at that point, and that is called as center of pressure. So where all the total sum of the pressure field will be acting on a body, so that is called as your center of pressure. So I have given the definition for total pressure. So it is defined as the force exerted by the static fluid on a surface. That is, the surface can be either plane or curved surface when the fluid is coming in contact with the surface, and this will be always act normal to the surface. And next is center of pressure. So here also I have given the definition, defined as a point of application of total pressure on the surface. Generally we can take there are 4 cases of submerged surfaces on which the total pressure force and center of pressure is to be determined. So those submerged forces can be your vertical plane surface, horizontal plane surface, inclined and curved surface. So in the next thing we are going to see the vertical plane surface that is submerged in a liquid. So we are going to consider a plain vertical surface of arbitrary shape. So arbitrary shape is, it doesn't have any shape, some shape is there. So this arbitrary shape is immersed in a liquid, and this is going to be the free surface of liquid. Okay, so you are going to consider a plane vertical surface of arbitrary shape which is immersed in a liquid. So let A be the total area of the surface. So the complete area is going to be the A. And H bar, you can see this G point is the center of gravity and P point is the center of pressure. So we are assuming that G point is center of gravity. So center of gravity is the point from which the weight of the body or a system is considered to act. So it is called as a center of gravity. Okay, for example, you can take the middle of seesaw. Okay, that is a simple. I can say that in a seesaw, in the center, your center of gravity will act. In similar way, let G be the center of gravity of the plane surface and P be the center of pressure. Okay, and where H bar will be the distance of center of gravity of the area from the free surface of the liquid. So from the free surface to the center of gravity, we are taking the distance to be H bar, and from the free surface to the center of pressure, we are taking it to be H star. Okay, and what we are going to do is we are going to determine the total pressure. So how can we determine a total pressure? It will be very difficult to determine a total pressure. So for these kind of cases, what we will be doing is we are going to divide the entire surface into a small number of parallel strips. So we can see that a small element here. So we are going to divide the entire surface into number of small parallel strips. So the force on the small strip will be calculated and the total pressure on the whole area is calculated by integrating the force on the small strip. So for one small strip we will calculate, and those things we are going to integrate, and after integrating we can get the force for the whole area. Okay, force for the whole area can be calculated. So how we are going to do this? So we are going to consider a strip of thickness dh. So we are going to take dh as a thickness of a strip and width of the strip be b. So and we are also imagining that it is at a distance height from the free surface of the liquid as shown in the figure. So this is how we are going to imagine. Okay, now how we are going to calculate the total pressure? So first thing is you are going to calculate the pressure intensity of the strip. So it is very simple. So we have learnt in the previous slide using our hydrostatic law, that is P is equal to rho GH. So this will be the pressure intensity for the strip, and next is area of the strip. So I have told that let A be the complete area of the strip. Then for complete area of the surface, plane surface of the arbitrary shape which is immersed in the liquid. Then in order to consider the area of the strip, we are going to take that as dA. So area is nothing but width into height. So here the width is B and height for the small strip or thickness for the small strip is dH. Okay, now what will be the total pressure force on the strip? So total pressure force, I am taking it as dF. So this is for strip, small strip alone. So dF. So dF is equal to pressure into area. Already we have learnt that pressure is equal to force by area, or stress is equal to force by area. So force will be equal to pressure into area. So here dF is equal to, my pressure what I have calculated is rho GH, and area is here, so B into dH. Okay, so for the small strip, the pressure force on the small strip will be equal to dF is equal to rho GH into B into dH. Supposing if I have to take for the whole surface, total pressure force on whole surface. So how we can do it is just we have to integrate it. So pressure will be F. So integral dF will be equal to integral rho GH into B into dH. So if we integrate this, I will be getting the total pressure. So what I am going to do is I am going to take the constant term. So rho G will be constant, I can take that as I can take that outside. So I am having H into BdH. Okay, so what is this BdH? So BdH is nothing but dA. So I can write that as rho g into H into dA. So my F is equal to rho g into integral of H into dA. So what is this H into dA? So we might have learnt that center of gravity is nothing but product of area into centroidal distance from the point. So what is this? Centroidal distance is going to be H and area is dA. So the something like that, center of gravity is nothing but product of area and its centroidal distance from the point. So you might have learnt that is my Cg is equal to integral y dA. That is my first moment of area. So you might have learnt in your engineering mechanics. So I am going to apply the same principle here. Okay, so what I am going to do is F is equal to rho g into integral H into dA. So you can see it is very similar to the center of gravity. Okay, so what is the formula for it actually? What is this HdA? I can write this as moment of surface area about the free surface of liquid. That is my center of gravity, and this can be written as area of surface into distance of center of gravity from the free surface. Okay, so area of the surface is going to be A and distance of center of gravity. So I can see that is H bar. So I can write A into H bar. So integral H dA is equal to A into H bar. So my F will be equal to, so what I am having, rho g into integral H dA. Rho g into integral H dA. But instead of H dA, I can write A H bar. So F will be equal to rho g into A H bar. And generally, we'll have the unit as Newton. Okay, so next what we are going to calculate is center of pressure. We are going to determine the center of pressure for this plane surface. So this center of pressure will be calculated using your principle of moments. Principle of moments or Varigon's principle. So we call that as Varigon's principle. So using this principle only, we are going to calculate our or we are going to determine our center of pressure. So the principle of moment states that the moment of force about any point will be equal to algebraic sum of the moment of its components about that point. In simply, what we are going to use, the formula we are going to use to determine the center of pressure is moment is equal to force into perpendicular distance. This you might have known. The resultant force F will be acting at P. That is, P is the center of pressure. You can see in the figure, that is, P is going to be the center of pressure and H star is the distance from free surface of the liquid as shown in the figure. So we are going to use this now. So moment of the force F about free surface of liquid is equal to, So what we have seen, moment is equal to force into perpendicular distance. Force is going to be F, perpendicular distance from the center of pressure will be H star. So this is what we are going to see. So as usual, we have subdivided into small strips. So moment of force dF. So we are going to calculate for the small strip and then we are going to integrate it to get the total force. dF is equal to dF into H. Okay, and we know that force is equal to pressure into area. So we know this, force is equal to pressure into area. So pressure formula we all know that rho into GH, and the area for the strip is B into DH. So this will be my DF because I am calculating for a small strip. Okay, so which is DF is equal to rho GH into B into DH. So now the moment of force will be equal to moment for the small strip is equal to, I am going to substitute 3 into, that is instead of dF I am substituting rho GH into BDH into H. Okay. Now what is the sum of the moments of all forces about the free surface? Sum of moments of all forces about free surface of liquid will be equal to so we'll be calculating the sum of moment of forces is equal to, we'll be integrating it, that is rho GH into B into DH into H. Okay, so in this I can write this as integral rho G H square into BDH. So I am rearranging it, nothing more than that. And also we know that BDH will be equal to dA. So we have seen in the last derivation itself. So I can substitute this. So I can take this rho G outside, integral H square dA. So what is this H square dA? So this is moment of inertia of the force about free surface of liquid. That is moment of inertia of the surface about free surface of liquid will be equal to integral y square dA, or here we can write it as integral H square dA. So this can be written as I naught. Okay, so sum of moments about free surface will be equal to rho G I naught. So I can write this as rho G I naught. I will be keeping this as equation number 5. Okay, so I can equate. So this is the principle of moments here, the one we are going to use it of. So what is our principle of moments? Moment of force about any point is equal to algebraic sum of the moments. So I have calculated the moment of force separately, which is my F into H star, and I have calculated the sum of moment of the forces rho G I naught. So when I equate these two things using, I am going to equate these things as per principle of moments. So as per principle of moments, I am equating, I can equate equation number 1 and 5. So which is F into H star is equal to rho G I naught. Okay, so what is F? Already we have calculated our F. So what is our F? Rho G into AH bar. So this is my F. So I keep this as equation A. Okay, so substitute this, I'll keep it as B. Substitute A equation in B. So instead of F, I can substitute A equation is, I am writing it once again, rho G A H bar. Okay, this is my A equation. So instead of F, I am substituting rho A G A H bar into H star is equal to rho G I naught. Okay, now I'll keep H star in left side, and all the things I am going to bring it to the other side, to the right hand side. That is, H star will be equal to rho G I naught by rho G AH. So I can cancel this rho G. So my H star will be equal to I naught by AH bar. So I have for bar. So this I keep it as equation number 6. Now by theorem of parallel axis, I naught is equal to Ig plus A H bar square. So this keep it as equation number 7. Okay, so I naught is equal to Ig plus A H bar square. So this Ig is moment of inertia about an axis that is passing through the center of gravity of area and parallel to the free surface of liquid, and I naught is going to be the moment of inertia about the base. Okay, now I am going to substitute this equation number 7 in 6. 7 in 6. So what is my equation number 6? 6 is nothing but H star is equal to I naught by AH bar. So this is my 6th equation, and my 7th equation is I naught is equal to Ig plus AH bar square. So this is my 7th equation. So simply substitute it. H star is equal to Ig plus AH bar square by AH bar, which is equal to H star is equal to Ig by AH bar plus AH bar square by AH bar. So this A and one H bar will get cancelled. So my H star will be equal to Ig by AH bar plus H bar. So this is the formula for center of pressure. So from equation, I can take this as equation number 8. So from equation 8, it is very clear that center of pressure is lying below the center of gravity of the vertical surface, and the distance of center of pressure from free surface of the liquid is independent of the density of the liquid. So this is the conclusion we come from this derivation. So I have given the statement here, you can go through it, and I will be giving some plane surface and what is the center of gravity from the face, its area, and its Ig and I naught. That is, the moment of inertia from the base is going to be I naught, and moment of inertia about an axis which is passing through the center of gravity of the area and parallel to free surface will be my Ig. So consider the plane surface, that is, which is rectangular in shape, and my center of gravity from base x will be equal to d by 2, depth is going to be d by 2, and area will be going to be b into d, and Ig is going to be bd cube by 12, and I naught will be bd cube by 3. So we have to remember all these formulas, and if you take for a triangular section, my h, that is the center of gravity from base, will be h by 3, and area will be equal to half into bh, and my Ig value is bh cube by 36, and moment of inertia about the base is bh cube by 12. So if you take for the circular section, that is circular plane surface, my Cg from base will be, x will be d by 2, and area will be pi d squared by 4, and my Ig will be pi d power 4 by 64. So these are the common sections we will be using to work out the problem. So in the next video we can see how to work out a problem on this topic. Thank you. Happy learning.